All right, today we are jumping into one of the most powerful ideas in AI right now, Retrieval Augmented Generation. You'll hear it called RAG, and honestly, it's a total game changer. It's what's turning large language models from kind of smart know-it-alls into actual expert researchers. So let's get into how this tech gives AI an open book to pretty much all the world's knowledge.
Just imagine this for a second. You've got thousands of internal company reports, tons of legal documents, maybe even just years of your own personal notes. What if you could just ask an AI a really complex question, and it could sift through all of that private info in seconds and give you a perfect, verifiable answer? Well, that's the world we're stepping into today.
So, think about it this way. On one side, you've got your standard large language model, an LLM. Its knowledge is basically frozen in time, stuck whenever it was trained. It can't know about stuff that happened yesterday, and it can also, well, hallucinate, which is a nice way of saying it just makes stuff up. But a RAG-powered LLM, that's a whole different story. It gets access to real-time information, and, this is the crucial part, it grounds its answers in specific, verifiable data that you provide.
Okay, so first things first, let's talk about the AI's memory problem. To really get why RAG is so brilliant, we first have to understand why even the smartest models out there have some serious, fundamental limits on how they access knowledge.
So, to fix that memory issue, we actually have to solve a completely different puzzle first. How do we get a computer to understand the meaning behind our words, not just the words themselves? Well, it turns out the answer is to translate our language into the one language computers are truly fluent in, math.
And this is the magic tool that does all the translating. It's called an embedding model. Its entire job is to take a piece of text, a word, a sentence, whatever, and turn it into a list of numbers. We call that a vector. But it's not just a random string of numbers. No, this vector is like a mathematical fingerprint for the text's actual meaning.
Okay, let's make this concrete. We've got a simple factual sentence right here. Now we're going to feed this straight into our embedding model. And poof, this is what the model spits out. Now, I know it just looks like a jumble of numbers, right? But believe it or not, this vector is the mathematical essence of that sentence. Every concept, capitals, cities, countries, it's all encoded right here in these numbers.
This right here is the absolute key to understanding everything. I mean, think of these vectors as GPS coordinates for meaning. So if you turn the sentence Paris is the capital of France into a vector, its coordinates in this, meaning space would be super close to our Riyadh vector. But the vector for the best way to bake a cake, that would be way, way off in a completely different part of the map. This idea of distance is everything.
So, now that we have these coordinates for meaning, what can we actually do with them? Well, we can build a revolutionary new kind of search engine, one that doesn't just look for keywords, it looks for concepts.
I mean, this is the challenge that every search system on the planet faces, right? If you've got a massive library with millions of documents, you can't just read through all of them every single time someone asks a question. You need a wicked fast, super effective way to find just a handful of documents that are most likely to have the answer.
And here's the deal. There's a trade-off. Using those vector GPS coordinates, what we call embedding-based scoring, is incredibly fast. It's perfect for quickly grabbing, say, 100 potentially relevant documents out of millions. But then, to find the absolute best matches in that smaller list, we can use a slower but much more accurate method to re-rank them. It's really the best of both worlds. You get insane speed for the first big search, and then pinpoint accuracy for the final result.
So here's how that search process actually works, step by step. First, you index all of your documents by turning every single one into a vector. Second, you store all those vectors in a special database that's built for this kind of thing. Then, when a user asks a question, you query by turning their question into a vector too. And finally, you retrieve by just asking the database, hey, which of my document vectors are mathematically closest to my question vector?
Okay, so we've built our super smart search engine. Now for the grand finale, the most exciting part, combining that raw retrieval power with the reasoning brain of a large language model. This is where Retrieval Augmented Generation really comes alive.
The best way to think about it is like a team of experts. You've got the embedding model, that's your translator, turning words into math. You have the vector database, that's the library, holding all the knowledge. The retriever is the super fast librarian who knows exactly where to find the right book. And finally, you've got the large language model, that's the brilliant professor who can read those books and put together a perfect synthesized answer.
So here's the entire flow, from start to finish. A user asks a question. Instantly, the system retrieves the most relevant documents from its library. Then comes the augment step. This is the real secret sauce. The system bundles those retrieved documents together with the original question, and finally, it tells the LLM, hey, generate an answer, but you are only allowed to use the information in these specific documents I'm giving you.
And I mean, this is literally what that instruction, what we call the prompt, looks like. It's basically an open book test for the AI. The documents are the textbook pages, and the user's query is the exam question. By forcing the LLM to stick to the script, you pretty much eliminate the chance of it going off and just making things up.
All right, let's wrap this up by looking at why this is such a huge deal. This isn't just some minor update. It is a fundamental shift in how we build and use AI. This is all about creating AI that is truly grounded in facts.
So let's just quickly recap the massive wins here. First, it crushes hallucinations because the answers are tied to real documents. It completely solves the outdated knowledge problem because you can update your document library anytime you want. It's way more cost-effective than constantly retraining a giant model. And maybe best of all, you get systems that not only give you an answer, but can cite the exact sources they used to create it.
And that really brings us to the most exciting question, doesn't it? RAG gives AI an open book. Your company's book, your personal data, the world's most up-to-date information. So the only real limit now is the quality of the questions we choose to ask. Thanks for tuning in.